So an exciting piece of test gear showed up today that gives us an important opportunity to talk about safety. The thing that we're building, the LIDAR Compass, fires a laser. And it fires a laser in a whole bunch of different directions, and it fires a laser in a continuous sweep throughout all of those different directions. So we want to make super duper sure that if that laser hits someone in the eye, it's not going to blind them. Now, as far as the LIDAR itself, this isn't a huge concern. It's an infrared laser that's used for measurement, and it's certified eye safe. It's really low output power, and the fact that it's infrared means that the LIDAR is able to sense the dot without too much trouble, even though the dot isn't altogether that powerful. So we can trust that the LIDAR itself is decently safe. What we probably can't trust at a glance is that the laser eye strapped to the thing for visual feedback is safe. So let's take, for example, this green laser pointer I've got here, which is definitely not eye safe. Now what I've got here is a low quality laser power meter, and it's probably not altogether that accurate, but I think it'll do well enough to illustrate the point here. So the way this works is there's a thermopile here, basically a Peltier element, and when you fire a laser at that black dot, this thing measures the heat output of the laser, assuming that the black surface absorbs a calibrated amount of that, a consistent amount of that light as heat. So if we try with the green laser, we have to wait for it to come up to a steady state. And eventually we see that this laser isn't crazy powerful, but at around 80 milliwatts, it's definitely super duper not eye safe. Now let's try this 405 nanometer laser over here. This one is certainly a bit dimmer if you look at it, but let's see how much less power it outputs. Right off the bat, this doesn't qualify as eye safe. So in the end, it settles somewhere around like 35 milliwatts, which is definitely still way too high. And the problem that I'm running into is that all of the sort of high visibility green 532 nanometer lasers you can get on Amazon have this same problem. Like, they all say that they're lower than 5 milliwatts and theoretically eye safe, but that's just total crap most of the time. And another thing that's super interesting is colors other than red very frequently are what's called Dpss, diode-pumped solid-state lasers, where the actual laser diode emits infrared, and that strikes a crystal that then re-emits at a different frequency. And in fact, it re-emits at two different frequencies, one of which is visible and one of which is actually a doubled copy of that frequency, which is in the infrared. So this is one infrared laser that outputs into a crystal that outputs visible and a separate infrared laser frequency. And all of them are lasers, so all of them, give or take, come out the front and can potentially cause eye damage. So I have this infrared cut filter here, and if we use this to filter the laser before it hits our power meter, so we're going to fire this green laser through the IR cut filter, and recall previously our power output was around like 75 or 80 milliwatts. We're going to notice with the IR cut filter in the way, that's a whole lot less. So with the IR cut filter in the way, we're topping out at like maybe 40 milliwatts. If I remove it, suddenly it shoots up, which means this green laser is outputting a ton of infrared, ton of laser energy that we can't even see, but it can definitely go ahead and blind us. So enter this little guy. Unfortunately, it's not cheap. I think this was like 50 bucks on DigiKey or 40 bucks on DigiKey. But what it is a whole lot safer. So this is a 520 nanometer laser, which is actually output directly with a diode. There's no infrared laser that then pumps a crystal or anything like that. It's just direct emission. And given that it comes from DigiKey, this thing claims that its max output is less than 1 milliwatt, and since I paid that much money from a tier 1 distributor, I bet that that's actually probably the case. So let's turn it on, and it has a nicer color, I think. It doesn't even register on the power meter. We don't even see it tick up to 1 milliwatt, which means that claim of under 1 milliwatt is probably pretty accurate. And I don't know, to my mind, it's certainly a lot less flashy than that 100 milliwatt 532 nanometer laser I was just firing, but you can still see it super well, definitely better than red lasers on all of the sort of bright reflective surfaces that we'll be hitting during the daytime. So, going with this guy, I think we're in good shape to see the feedback laser and also not blind anyone. You know, critical requirement for any good project.